Hello, ladies and gentlemen, and how are you this evening? Okay, so I spent a good amount of time today going over the proof of the product rule with a number of students, and I thought that I would make that available to a few more of you via the LMS. So let's take a look. I remember doing this in class, but let's look at it one more time. Product rule. So what we want to do is we want to prove if h of x equals f of x, g of x, then h prime of x equals f of x, g of x, plus g prime of x, f of x. And let's see if I can get everything on the page. Oh, wrong way. What if I go this way? Yay. Okay, so that's what we want to prove. Now, look at, do you see this? This f prime of x? F prime of x, by definition, is given by the limit, as h approaches 0, of f of x plus h minus f of x over h. And this guy here, it's given by definition, the limit, as h approaches 0, of g of x plus h minus f of x over h. So I'm going to want to be looking to build this and this from the information that I'm going to be able to work through. Okay, just keep that in mind. Okay, that's just another way of writing it. By definition, that's what that means. So we'll keep that in mind. Now, what we're trying to do is we're trying to figure out the derivative of h of x. So by definition, the derivative of h of x is the limit, as h approaches 0, of h of x plus h, that's a different h, minus h of x over h. That's the definition of the derivative of a function. Okay, the function happens to be h of x. But we happen to know that h of x is in fact made up of two other functions. We know h of x is equal to f of x and g of x. Therefore, h of x plus h is equal to f of x plus h times g of x plus h. Therefore, if we do a substitution, people, this h of x plus h gets substituted by this, and this h of x gets substituted by this. So we're going to do a straight substitution, and that takes us to the limit, as h approaches 0, of f of x plus h, g of x plus h, subtract f of x, g of x, all over h. That's wonderful. That's what we have. And no thinking involved. It's just substitution and a definition. That's all that's happened here. Now, let's go back to what I said. This is what I want. I want to come up with some of these. Out of these, I want these out of these. So what I'm going to do is I'm going to think for a minute. I've got an f of x plus h. I really wish I had an f of x plus h minus f of x. Well, there's an f of x. Yeah, but I got a g of x plus h and a g of x, and they're not the same. I can't common factor them out. I really wish this g of x was a g of x plus h. Gee, I really wish that I had this. I wish I had this. Now, I wish I had that so much, I'm going to put it in there. But so it doesn't make any differences at all, I'm going to also include this. So I really want this, and so I don't change the question at all. I'm going to put in this as well, because this and this will cancel each other out, which leaves me with and let's notice what's happening here. That's actually just 0. But I really, really wanted that. Why? Because it's got a g of x plus h. That's got a g of x plus h, and I can common factor it out. So I'm really excited about that. So what I'm going to do is I'm going to break this up first of all. I'm going to do the limit as h approaches 0, and just not to do any sudden moves to scare anyone off, let's rewrite this. And let's rewrite this. So what I did here is I took this whole thing and I said, you know what? I'd like to break you up. And that's not a new concept. Let's just think from here. If I had 3 plus 5 over 2, I could do 3 over 2 plus 5 over 2. That's what I did. They're all over h, so I took this point here, and I put this one over here with over h, plus this one over here. And I took the limit, and I just said, well, you know what? I'll just distribute that limit in there. I don't think that's hard to understand. I think you can follow that. But the really exciting part, the very exciting part, is do you see this? Do you see this? That's so exciting. I'm going to common factor it out. And that's going to leave me with a g of x plus h with an f of x plus h minus f of x all over h. Plus, do you see this? Do you see this f of x? It's the f of x I'm going to factor out this time. And it just gives me tingles down my spine to think about that, because that'll leave me with a g of x plus h minus g of x. So that's going to give me the limit as h approaches 0 of f of x with a g of x plus h minus g of x over h. And you're starting to see these things come to fruition. These things are now here. So now the limit of a product is the product of the limits. That's a 0. And this is the limit of f of x plus h minus f of x over h plus the limit as h approaches 0 of f of x times the limit as h approaches 0 of g of x plus h minus g of x over h. And what I have here is this times this plus this times this. And if you look really closely at this, and if you think for a minute, you're going to see that as h approaches 0, this is going to approach 0, so this whole limit is going to approach g of x. And this whole thing, you should know that that is in fact, by definition, f prime. And as h approaches 0, f of x just doesn't give a darn. And this, we should know, is g of x. The addition falls down, and lo and behold, what we have, unbelievable, is the derivative of the first times the second plus the derivative of the second times the first. And we are just so happy that we're able to complete this proof. Okay, guys, there's the product rule proof. See ya.